Alright, this is part 2, talking about the beginning of infinity. So a comment on last time. I looked up how old starlight is when we see it, and the oldest we've seen is 9 billion years old. That's around double the age of the Earth. Anything we see is generally pretty old. The 10th closest star is around 10 light years away, which means when we see that light, the light is already 10 years old. And that's one of the closest stars that there is. So it helps you understand that this is different than an experiment that we set up on Earth, that we control it, we create the entire thing, and then we create the evidence and observe it. We're looking at stuff that was already there. Most of it was already there before you were born. One of the stars we've seen is 13.8 billion years old, which is similar to the age of the universe. That one, when we see the light from that, it is 6,000 years old. So very, very old. Although not very old compared to how old the star is. Because we're seeing it 6,000 years old, but the star is 13.8 billion. That's way, way more. So the point is how distant these things are, how far outside our experience they are. There's a huge gap between physical reality and what we're used to on Earth. The kind of circumstances we have experience with directly. Okay, so now we're going to talk about empiricism. Note, there are not diagrams in this copy of the book here. You can use your own copy. I do have a PDF that has the diagrams in them, but I'm not using it because there's larger borders around the edges of all the pages and the page breaks, so I don't like it as much. It wastes more space. But I can show a diagram if I need to. Often they're not that important anyways, or you can look in your own book. So David starts talking about what empiricism says. Maybe nature writes ideas into us via our senses, or we read ideas from the book of nature using our senses. That's wrong. We guess theories by, quote, rearranging, combining, altering, and adding to existing theories. So we're not deriving scientific theories from observation. We're actually looking at the theories we already have and playing around with those to get new theories. Observation still plays a role, but it is a different role than empiricism thinks. We don't directly learn from observation. It's useful in some way, but it's not the primary thing in center stage. So David says the mind is not blank, which empiricism calls white paper sometimes, at birth. We have some ideas inborn. These are changeable, by the way. David is not saying we're born with a bunch of ideas that determine our personality or something, nor does he think that our genes determine our personality. He's just saying that we have some initial ideas, but we can change them just like the ideas that we create later on. I've talked with him about this a lot, so that's not all in the book, but I know what he thinks. David says we use experience to help us choose between theories. He does not explain how that works right here in this part. But as a basic summary, we can try to observe things that will contradict at least one of our theories. If we have two theories and they disagree with each other, we can figure out what can we observe, what experiment can we do that will get us data about something they disagree about, and then at least one of them will have to be wrong. It won't match the data. So we can use experience to help us reject theories, to help us criticize theories. So the rough idea is we learn by taking our theories and trying to improve them and rearrange them and brainstorm and so on. And then what keeps us connected to reality is criticism. We use observations and sense data in our criticism. So if our theorizing gets too far away from reality, we're going to notice the error in the critical stage. So David talks about that more later. I forget exactly what he says about it because I haven't read this book for a long time. So I know what the idea is, but I don't know exactly how much he covers it and when. Okay, so this paragraph right here is very long and big. So I skimmed it, and I thought, hey, this is pretty hard to understand. It's pretty hard to wrap your head around something that's so giant, which I do think is a writing error. It would be better if he had organized things a little bit more. I think this one should have been 2 main paragraphs. So you can see that in my tree diagram. The first sentence is actually kind of separate, and then the teal part should have been 1 paragraph, and then the blue part should have been a different paragraph, because they're kind of making different points, and it's just too much all at once. So I actually made multiple diagrams about this, and I recorded them, and there will be a link in the description where you can watch me making the diagrams if you want to. However, I focused mostly on making the diagrams, not on explaining what I was doing. So there's less teaching in there. But what I did roughly is I broke the paragraph into sentences. So here are all the sentences, and I paraphrased them. Some of the paraphrases are very short, and some are a bit more detailed. It depends what I thought might be useful. And here is the same sentences, but organized more in how they're connected to each other. And here's my final version where I paraphrase more, and I don't go sentence by sentence. I try to go idea by idea. I think, what is each idea in the paragraph, and then I put them together. And I also did this for the next paragraph, so that's below. So this is the final version that is more focused on ideas rather than sentences, but at the beginning I wasn't really sure what to do, so I went sentence by sentence. So the topic sentence here is misleading. It makes you think the paragraph is going to be about Karl Popper and how he properly understood things and corrected empiricism. But the rest of the paragraph doesn't actually talk about Popper and what his ideas were. So just kind of set that aside and think of it as a minor note. So then part 2 of the paragraph goes from here until right here. So the topic here is what's good about empiricism. So it's not all bad. David wants to recognize that it was helpful in some ways. So it defended experimental science. It said we can observe things and we can learn. Some people didn't even think we could learn new things. So it was optimistic that our observations were actually useful, not just tricking us with errors, the delusions of the senses or something. So empiricists thought observation was useful and it could help us understand reality and we could learn new things, that human senses were actually worthwhile and useful tools, and especially they rejected intellectual authority. There are many different types of authority, but the idea was you could challenge those things. You could say, oh no, I'm not going to believe this holy book, I'm going to believe what I observed. I'm going to put my own powers of observation and reasoning ahead of what the priest tells me, or what the academic tells me, or what traditional lore says, or what an ancient book says, whether it's holy or just famous or whatever. So we don't have to just listen to whatever we're told by things that have high social status or popularity or some sort of claim to being special and important, like holy. So enabling people to think for themselves more was a really good thing that empiricism helped with historically. All right, now this other part of the paragraph brings up a challenge to empiricism. So new topic, try to learn a different point here. There's a difficulty with empiricism, and it was something people thought of near the beginning and tried to ignore or proceed anyways, or they figured they'd figure out a solution later, or they came up with a bad solution and thought it worked, or something. So the question is, how can knowledge of what has not been experienced possibly be derived from what has been experienced? How can you derive non-experience from experience? Or how can you get the known, or the unknown from the known? So there's a kind of gap between the things you know, or the things you have experience of, the things you've observed, and the things you don't know, don't have experience of, have not observed, and how can you connect one to the other? So there's a difficult problem there about how to do that. But it does not come up in the Popperian approach to learning that I was talking about earlier, where we guess things and we play with our ideas to try to come up with better ones, and then we use observations to criticize our errors. In that approach, you're not trying to make a jump across this particular gap. You're just doing something else. So David points out that the geography on Mars cannot be derived from the geography of Earth. Your knowledge about Earth geography is not going to apply to Mars geography. So then why would our knowledge of Earth physics apply to Mars? If we're in a different place on Mars, why would the physics be the same? We've experienced physics on Earth, but why would it be the same over there when geography that we've experienced on Earth is not the same over there? So some things seem to kind of like you can derive them from one place to get the other place or the other thing. And then other things it doesn't work with. It seems to work with some things and not others. As like a first impression where it works with the physics but not the geography. And David says that deduction is not enough to bridge the gap. This is a well-known thing. Lots of thinkers knew this in the past, that just using deductive logic would not solve this problem. So, from that paragraph, empiricism helped science, but it couldn't answer the tough question, and logical deduction also cannot answer that tough question. So, next paragraph is about repetition and induction. So, I made a chart again. So, here's all the sentences in the paragraph, and then I arranged them. You can pause if you want to look at this stuff more closely, by the way. And then here's my final version. So I was trying to understand which sentences are related to each other, how are things organized. And then finally, to do it more by ideas instead of sentences. And figure out what should we learn from this, what's important, etc. Okay. So this paragraph is a bit more thematic than the first one, which had two main separate parts to it. It's also a little bit shorter, but it's still a lot of stuff all at once. There's a lot of long paragraphs in the book, but some of them are shorter. Like these two are shorter. This one, that's pretty long again. Anyways, that's one of the things you have to deal with. But if you have trouble, you can try to break it down. You can try to understand each sentence one by one, and then understand the connections between the sentences, and then understand the overall full point of the paragraph. That way you're not just trying to understand everything at once, you can do it step by step. So the main idea here is empiricism says that we can do repeated observation and generalize our observations to find patterns which we can predict. And then, if our predictions are correct, then our knowledge gets more reliable. But if they're wrong, then we could refute our knowledge. And this approach is called induction. And one little caveat David mentions is that the predictions apply to similar circumstances. Like the same thing is likely to happen again in similar circumstances, but not different circumstances, which actually brings up a major issue is all circumstances. If you take any two sets of circumstances, you could find some similarities and you could find some differences. So how do you know which circumstances are similar? How similar is similar enough? And which types of similarity are the important ones? It's not just a matter of degree of similarity. People think of things as having some single number or amount of similarity, like it's one thing. However, there are always infinitely many different points of comparison you could make between two things, and you could figure out how similar they are on every single one of those infinitely many things. And they do not sum up or combine into a single measure of similarity, which is a major problem. I've talked with David about that. I'm not sure if it's really covered in the book or not. I don't remember. So the classic example is the sun will rise because we saw the sun rise yesterday and the day before and the day before and the day before and so on. And David is challenging that way of thinking about things. It has some appeal, like a lot of people would hear that and say, okay, that seems pretty reasonable. But if you want to know in detail how science really works, there's actually different stuff that works better, makes more sense. So because induction has logical problems, people tried to defend it. And one of the ways they did that was they said, well, there's a principle of nature that makes it work. So logically, it wouldn't really work. But we live in a world where it does work. So there must be like a law of physics that just makes it work. And so they've tried to come up with principles like the future will resemble the past is a popular one. And David mentions it could be the distant resembles the near or the unseen resembles the seen. And you could actually do this for many, many different things, he says, and so on. Which is what I was saying about similarity. There are infinitely many dimensions of potential similarity. Like, you could have similarity in location. Is it distant? That's distant is a difference, a type of non-similarity. Or is it near? That's a type of similarity, a similar location. And you can have similarity over time. Are things at a similar point in time? Or are they far apart in time? And you can have similarity of hiddenness, like how easy is it to see with the human eye? Or how hard is it to see with the human eye? Or have we seen it or not seen it? Those are different categories where you could distinguish things as being similar or different. And you can actually do that with any possible observation tool, like not just the human eye, but a camera or a different camera, any design of camera. And you could say, seeable by this design of camera or not. And then you could categorize things into the two categories and say they're similar if they're in the same category or not similar if they're in different categories. And since there are infinitely many possible designs of camera that you could imagine, then you got infinitely many characteristics which you could measure similarity according to. Which is problematic when you're trying to say things like, our prediction will hold as long as circumstances are similar. But if you haven't specified what types of similarity you're talking about, that's not good enough. So one of the things they're doing when they say the future will resemble the past is they're saying that they're expecting things, their predictions will work even though there is a difference, a non-similarity, which is time-based. So they're saying even though we're basing this on past observations and we're making claims about future observations, so those are different in terms of time, we think that the pattern will hold anyways. So they're specifying some information about some types of similarity that they're interested in, but there's still all the other ones that they have not specified. So about that paragraph, main points. Empiricism says we derive with induction, which means we're finding patterns across multiple observations. Some of our observations repeat, which lets us find a pattern. And then we predict the pattern will continue in similar circumstances, whatever that means. And then if our predictions turn out to be correct, that increases the reliability of our knowledge. And if we get correct predictions over and over again, our knowledge gets really reliable, and that's how progress happens. That's the idea. But that's wrong. So no one has actually come up with a principle of induction that works for practice for scientists. So no one's come up with one that scientists can use in order to do science, says David. And he says that most criticism of induction has focused on 2 points. One, that there's no practical inductive principle that scientists can actually use to do their work that anyone has figured out. And 2, there's the logical gap. How do you connect the experienced with the non-experienced, the known with the unknown, the future with the past, the near with the distant, etc.? And deductive logic is not enough to connect those things. And so there's a very tough question about how do you connect them. So these are 2 of the main criticisms of induction that people have talked about. But David says, actually, induction is a lot worse than that. And he says he's going to tell us its 2 biggest errors that are more important than these errors. And that is what we'll be talking about in the next video. One of the things that's a little unclear here is whether David is including Popper in the historical criticism, or if he's getting his 2 bigger errors from Popper. He does not say that yet. So maybe we'll talk about that later. So quick recap, what should you take away? We learn by guessing, not deriving. It's also an active process, not a passive process. Empiricism, although wrong, had some value, and induction is this idea about repeated observation, generalizing or pattern finding, and prediction. But it's wrong, and one of the problems with it is the logical gap. Logic cannot take a bunch of experiences that you had and then derive something you have never experienced. One of the reasons for that is any finite data set is compatible with infinitely many patterns. That's one of the major difficulties with induction. It says find patterns, but there's this question, which patterns? That's something I might talk about later in more detail. But it's one of my favorite arguments about induction, the which pattern issue, because there are always infinitely many, and how do you select from this infinity of which pattern is important and which patterns are not important? It's something that some inductivists know about and acknowledge, but then a lot of inductivists are like unfamiliar with it and assume it's like false or try to deny it or something. Which is weird because some of their leaders and scholars are familiar with that problem and know it's a real problem. But then most of the fans of induction seem to not actually understand what that problem is. So if you want to know more about inductivism's flaws, subscribe for part 3. When you subscribe, you want to click the bell and then click on all. Otherwise, you won't actually get many notifications, if any. Also, if you like the video, more people will see it. It affects YouTube's algorithm.